Okay, so our next topic is all about acceleration. So what is acceleration? What do we mean when we say acceleration? When the object is accelerating, so there are two types of this one. Let's say accelerating. What do we mean by that? Is that meaning the object picks up velocity. The object moves faster. Again, uh, the velocity increase. When we say decelerating, the object slows down or move slower, so the velocity goes down. So by definition, acceleration symbolized by A is nothing but the change in the velocity of the object per unit time. So in short, we wanted to know how much is the change in the object's velocity. Okay, so meaning if there is a change in the velocity, then there is acceleration. If there is no change in velocity, then the acceleration is zero. To put this one graphically, to illustrate this one, let us start here. Gaussian plane. So normally this is our time in seconds, and this is our position or displacement of the object in meters. The slope of this one, let's say we have here a slope, is velocity. So we get velocity. Finding the slope of the 2 points, we get velocity. Now, let's say if we graph if we graph this is time. If we graph velocity meter per second, what do we get? So if we graph velocity versus time, we actually get acceleration. So acceleration is the slope of time versus velocity. So in general, if we have here, um, let's say, uh, velocity, which is the change in displacement over the change in time, then acceleration is the change in the velocity of the object over the change in time. Okay, so they are actually connected. Let us have a quick sample problem of this one. Let's say this person start at position A and moves to position B. So the initial velocity of, let's say, this boy is 3 meters per second. Now the final velocity is 10 meters per second. Now let us assume that it takes about 2 seconds for this boy to change from 3 meters to 10 meters per second. Now the question here is how much is the acceleration of the boy? So acceleration is the change in velocity over the change in time. So change is equivalent to final velocity minus initial velocity over and the change in time, we could say time final minus time initial. But since we already know that it took 2 seconds for this change, so we just simply have Vf minus Vo over 2 seconds. Now for the final velocity of the boy, the meters per second, so we would say 10 meters per second minus initial velocity is 3 meters per second. So this is the initial velocity of the boy divided by 2 seconds. So 10 meters per second minus 3 meters per second, we end up with 7 meters per second divided by 2 seconds. And so the acceleration is 3.5 meters per second squared. What does this 3.5 meter per second squared mean? So this just implies that in every second, the velocity of the boy changes by 3.5 meter per second. Let us have another example. Okay, so let's say this is position A and this will be our position B. So assume that this is round. Assume that the path is circle. So this is circle, so we have to make a one variable r. So this is r. This is the radius. So let's say this is 10 meters. Okay, so still have the same person earlier. Assume that this boy um, travels 10 times. So it moves 10 times around the circle. So it moves 10 times. And we wanted to know how much is the acceleration of the boy if 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 it starts at 6:30 a.m. and finish at 6:50 a.m. Okay, that's all. So we wanted to know the acceleration. We know that acceleration is the change in velocity over the change in time. So we have to know what is the final velocity and then initial velocity and then time final minus time initial. We're going to assume that the initial velocity is 30 meters per second and the final velocity is 1 meters per second. You might be tempted to actually solve the problem using this equation. However, it is not always the case. So you better first analyze the problem before doing any mathematical calculation. Now, if we look at the illustration, the boy moves 10 times. So it starts here. So 1, that's the first, 2, 3, 4, 5, and another 5. So you would notice that actually the initial position of the boy is also the final position of the boy. It means that the displacement of the boy is 0. Now, if the displacement of the boy is 0, meaning that the velocity is actually equals to 0. Now, if the velocity is equals to 0, if the velocity is actually equals to 0, the change in velocity, the initial velocity, the change in velocity over the change in time must also be 0. Okay, so the answer to this problem is 0. There is no acceleration considering that there is no velocity.